Why is it so crucial to standardize sodium hydroxide? This is the question that often bounces around in the minds of chemistry enthusiasts and scholars alike. Well, to put it simply, standardizing sodium hydroxide ensures consistency and accuracy in experimental results. Without it, we'd be left grappling in the dark, wrestling with inconsistent data and unreliable outcomes. So, let's unravel the mystery of preparing and standardizing 0.1 normal sodium hydroxide step by step. To kick things off, you'll need some essential items. These include sodium hydroxide pellets, distilled water, a weighing scale, a 1-liter volumetric flask, a glass rod, a 50 milliliter burette, a funnel, phenolphthalein indicator, and 0.1 normal hydrochloric acid. The first step in this intriguing science experiment is to calculate the weight of sodium hydroxide required to prepare 0.1 normal solution. A simple formula is used. Normality equals weight in grams divided by equivalent weight. In the case of sodium hydroxide, the equivalent weight is 40. Therefore, to prepare 1 liter of 0.1 normal sodium hydroxide, 4 grams of sodium hydroxide pellets are needed. Once the necessary weight is calculated, the sodium hydroxide pellets are carefully weighed. The pellets are then slowly dissolved in about 800 milliliters of distilled water in the volumetric flask, using the glass rod to stir until completely dissolved. The next step involves diluting the solution to the 1 liter mark on the volumetric flask. This is done by slowly adding more distilled water. It's important to remember that the solution needs to be cooled to room temperature before making up the final volume. Now, it's time to move on to the standardization process. This involves titration, a technique used to determine the concentration of an unknown solution by reacting it with a solution of known concentration. The sodium hydroxide solution is filled into the burette. About 10 milliliters of 0.1. Normal hydrochloric acid is pipetted into a conical flask, and a few drops of phenolphthalein indicator are added. The hydrochloric acid solution will turn a faint pink color. The sodium hydroxide solution is then slowly added from the burette to the hydrochloric acid solution while continuously stirring. The end point of the titration is reached when the pink color disappears, indicating that all the hydrochloric acid has reacted with the sodium hydroxide. By noting the burette reading, you can calculate the normality of the sodium hydroxide solution using the formula: normality of acid times volume of acid equals normality of base times volume of base. In a nutshell, the process of preparing and standardizing 0.1 normal sodium hydroxide involves calculating and weighing the required amount of sodium hydroxide, dissolving it in distilled water, diluting to the mark, and then performing titration with a known solution of hydrochloric acid. This meticulous process ensures accuracy and reliability in scientific experiments. So the next time you find yourself in a lab, surrounded by flasks and burettes, remember the importance of standardizing sodium hydroxide. It's not just a routine process, it's the foundation of precision and accuracy in the captivating world of chemistry.
Enjoy some classes. We provide you with valuable and up-to-date knowledge about the pharmacy education. We create entertaining yet informative videos on topics such as chemistry of drugs, biochemical reaction, and much more. Hit that subscribe button and press the bell icon and join our mission to make understanding pharmacy easier for everyone. Like, share, and comment on our videos. We look forward to hearing from you.
Johnson Classes.
The best for best.